Hello everyone, this video is the continuation part of our event Cloud Vision. The pipeline looks like this. You will upload an image to an S3 bucket. That upload will automatically trigger a Lambda function. The Lambda function will call to recognition to detect faces in the image and extract facial attributes. The result will be written back to the same S3 bucket as JSON file. Here everything is serverless. You don't need to manage any server. You simply load an image and the rest thing happens automatically. Today you will be doing a hands-on practice session with the three core AWS services. First one is Amazon S3, followed by AWS Lambda and Amazon Recognition. By the end of this session, you will have built a fully functional serverless image analysis pipeline entirely on AWS. Before we start, let me walk you through exactly what we have set up for you and what you will be building today. Before you can work with AWS, you need credentials, a user account with the correct permissions. We have already created an IAM user account for each of you. Here IAM stands for Identity and Access Management. It's a AWS permission system. So we have already sent you the credential email. Please open that and copy your respective credentials, which includes the IAM username and IAM password. After the successful sign up, this screen will appear. So let's start. So first of all, we will create a S3 bucket. Wait until it gets loaded fully. If you don't find it on your home screen, please search here. You'll get it like this, S3. Click on the first one. Then we need to create a bucket. Click create bucket here. Leave everything as it is. Now for the bucket name, we need to create a bucket name which is globally unique. Like in my case, I am creating by name bucket followed by my name and any number. Then we don't need to do anything over here. Simply click on create bucket. By the time, please make sure your region name. Now as we have created our bucket, then we need to add a Lambda function. For that, again come to the search console, search for Lambda. Then create function. Then we will give it a name, like in my case I'm giving it as a code file. Then we need to select the runtime. Here we will be running a Python code. Then we will select here a Python 3.14 as a runtime. Then we need to change the execution role. The role we have already. Then in the execution role section, click on use another role. Then choose an existing role. You will see one or two options. Select the first one. Then go for create function. What basically AWS Lambda does is, it's just a serverless compute service. The serverless doesn't mean there is no servers. It means you don't manage them. AWS handles all the infrastructure. You only write code. You only pay for exact millisecond you run the code. Lambda functions are event driven. They do nothing until something triggers them. A trigger can be an API call or a scheduled timer or an SNS notification. In our case, a file upload to S3 is the trigger. When a new image is uploaded to S3 bucket, S3 will fire an event, Lambda will receive that event, then it will run a Python function followed by calling recognition and write the result back, all automatically within just a second. Now paste the Python code that we have sent. Now let us discuss about the Python code. Here we have imported three things. First one is JSON. Like JSON is Python's built-in library for working with JSON. We use it to serialize our recognition result into a JSON string before uploading to S3. Next comes the Boto3. This is the AWS SDK for Python, the official library that lets Python talk to any AWS service. Without this, your Lambda function cannot communicate with S3 or recognition. Next is OS, the operating system interface module. We import it here as a convention, useful if you want to read environment variables. It is not directly used in this script, but it is good practice considered. Next, these two lines create clients, objects that represent a connection to a specific AWS service. The Boto3 client for S3 lets you call S3 APIs, which is put object, get object, and list buckets, and so on. The client for recognition lets you call recognition API, in our case detect faces. Notice these clients are created outside the handler function. This is intentional. Lambda reuses the same execution environment for multiple invocations. Creating client outside the handler means they are initialized once and reused, which improves the function and performance. The next is the Lambda handler. Lambda handler is entry point for every Lambda function. AWS calls this function when the trigger fires. It always receives two parameters, event and context. The event object contains all the information about what triggered the function. In our case, it is S3 event. So let's add a trigger. So for adding trigger, click here at add trigger. Then we will select a source. Here we will select S3 as our source. After that, we need to select our bucket that we have recently created. Leave everything as it is. Click here as acknowledgement, then add. We have successfully added the trigger over here. Now back to the code. Calling the recognition. This is the core of the function. We call detect faces on the recognition client. We pass the image location using S3 object. We give it a bucket name and key. Recognition will fetch the image directly from S3 object and process it and return the results. Notice we never downloaded the image into the Lambda's memory. Recognition reads it from S3 directly. This is efficient and avoids memory limits. Here the attribute parameter is set to all. This tells recognition to return every facial attribute that it can detect. Age, range, estimate, emotion, gender, eye direction, mouth open or closed, whether the person is wearing glasses or not, smile detection, and more. If you only want bounding boxes, then you can pass default as the value instead, but all gives you full picture. Next is the preparing the result. We construct a clean result dictionary. We record the image file name and the facial details array from recognition's response. Face details is a list one entry per face detected in the image. If the image has three people, faces, and details, the details will be three entries. Each entry contains all the facial attributes we requested. Now let's test what we have done. Now let's test it. After you fill all your details, click on Save and Continue. Then upload your image of your desire. Here I have uploaded an test image. Make sure your image name is small like test, sample, anything for smooth execution.